One of your homework questions involved two cars, one of which was moving at constant velocity and the other of which was stationary and began accelerating. And the question was, what acceleration does it need to have so that they meet when the first car catches up? Let's look at an example of that. One car is moving at 20 meters per second. A second car begins accelerating when the first car is 250 meters behind it. What acceleration is necessary so that they match speed at the instant the first car catches up? The acceleration is for the second car. Um, so the first thing we need to do is convert kilometers per hour to meters per second. I've already done this in my example, but you'll need to do it on the homework question. That's a simple calculation. Next, what is the equation for the position of the first car compared to the second? Well, the position of the first car is moving at constant velocity, so distance is just equal to velocity times time. Subtract out the 250 meters because it's behind the first car by that much at the very beginning. So what's the equation for the position of the second car? Well, the second car is going to be at a position of 1/2 its average velocity times time. Its average velocity, so the equation is basically the same equation as the first equation up at the top, but its average velocity is going to be changing from its final velocity to from its initial velocity to its final velocity. Its final velocity is going to be the same velocity as the first car because we want them to be going the same speed exactly at the same time that the first car catches up. So we've got to set these two equal to each other. So we have 20 meters per second times time minus 250, that's the position of the first car, is equal to 1/2 times 20 meters per second plus 0 meters per second times time, and that's the position of the second car. So let's rearrange this, solve the right side there. The 0, of course, is pretty easy. Times 1/2 makes that 10 meters per second. So let's solve this and get all of the velocity times time on the left, and we'll put the 250 meters on the right. We get 10 meters per second times time is equal to 250 meters, which means 250 meters divided by 10 meters per second is the time. So the time that the first car catches up to the second car is 25 seconds. Now that's not the entire answer. Now that we know the time, we can calculate everything else. The time was 25 seconds. That's when they meet. So the next thing we do is, where do they meet? We can pick either car. The first car is pretty easy. The equation was just its position or distance is equal to velocity times time minus 250 meters. So we have 20 meters per second times time, 25 seconds. Subtract the 250 meters. Well, 20 times 25 is 500. Minus 250 equals 250. So they're going to meet 250 meters in front of the first car. That's when the second car has gone 500 meters. What is the acceleration that's necessary? Well, since we know the time and we know the distance and we know the velocity, we've got pretty much everything that we need in order to calculate acceleration. We didn't really have to do even the distance calculation. The acceleration is equal to the change in velocity divided by time. We know that the second car is going the same speed as the first, 20 meters per second from its starting velocity of 0. So the change in velocity is 20, divided by the 25 seconds that it took for them to meet, and we have 20 over 25, which is 0.8 meters per second squared. Now, I included a lot of extra calculations in here that aren't necessary. This last calculation, once you know the time, is the only thing that you really need in order to answer this question. I hope this has helped.